Hello. Yeah, sorry that took so long to figure out what's going on. Now, Gary, you're off stage. I'm going to turn you on stage so that any viewers can see you. So you are there now. So I know people will be filtering in, as obviously few people are having actually trouble getting in this session too for some reason. I don't know why. Weird, because all the other sessions were fine. But I will turn everything over to you, and let's start going.
Yeah, next time I will go to your office and do the presentation there. No, I mean seriously, I will do that next time.
Okay.
Entire screen, awesome. So we only have 30 minutes left, so let's get the show started. Hello, guys. Sorry for the late. A little bit late here. Technical difficulty, but we have about 40 minutes left, so we'll just quickly go through it. Mark, you can hear me, right?
Yes, we can hear you.
Awesome. So basically, Mitsubishi Electric, we recently just did our own office retrofit project with VRF system and VRF system to replace our rooftop unit because we want to be in line with Mitsubishi Corporation. So which is more than 100 years in business with 150,000 employees close to it, and then with 213 consolidated subsidiaries. So we are definitely here for a long time. So that's why we want to create a vibrant and sustainable society through our technology, innovation, and creativities with our own system. So without further ado, want to do a little bit background is why we want to do the retrofit and why we think it is necessary. So for example, over here, so Mitsubishi headquarters is being in Macon for about more than 30 years. And so we're currently occupying about 20,000 square foot of first floor for this office. So existing equipments are, first one is the rooftop unit. So the first one is the rooftop unit. It is a 90-ton R22 rooftop unit. So there are electric heating coil and a duct heater. However, the electric heater coil inside the rooftop unit has never been used before. And for this building, in the main office area, there has never been natural gas for heating. So existing cooling system is an R22 90-ton rooftop unit for the first floor. And we are using fresh air combined with recirculation air, pretty much very similar to a typical rooftop unit that we typically see when you're driving on 401. When you see all the rooftop unit, they do have about recirculation from the room and fresh air from the outside. And it does come with a time-based setback as well as seasonal switchover between heating and cooling. However, the main reason to replace it is, first one, it is a R22 rooftop unit that has been around for more than 30 years. And on top of the main cooling system, we also have cooling for server room, which at the moment, before, we're using 3 pieces of Mitsubishi cooling only system. And it's still operational when we switch it, but it's just old piece of equipment, and then we want to switch it to a much more environmentally friendly refrigerant at a time. So we replace that with 2 pieces of cooling only system with R410A. Existing heating system, there are many different heating systems. For example, we're using VAV box inside the ductwork. Again, very, very typical for like a rooftop unit. with VAV box, variable air volume for different spaces. And we have parameters heaters around the office. Again, they are electric heat. So electric heating usually have a COP of 1, which means whatever power input is whatever power heating output is. And on top of that, we do have, we back maybe 10, 15 years ago, we're using VRF with geothermal. So we do have geothermal equipment that's using it with our VRF system. So some of the challenges is, first one is because we are, even though we've been here for more than 30 years, we still lease the building. So the landlord's requirement was to utilizing is that we are not touching the ductwork, we're not touching the VAV box, the heater, everything. If Mitsubishi Electric is to move, then everything needs to be back to its original, original design and equipment. So therefore, we are not using ductwork. We're not touching the ductwork. We're not using the VAV box. The ductwork we can utilizing wherever we can, but we are leaving majority of the office building untouched. Another challenge is it comes with smaller offices. Therefore, and then in some of the areas that may prevent VRF being utilized due to CSA B52. And lastly, we do have existing geothermal loop that has already been utilized before, and it will be utilized for future usage. So we really try to convert the entire first floor with our VRF technology. So, and however, one thing we do have in mind is because we want to utilizing heat pump with inverter-driven technology, because outside air keep on changing, right? The temperature keep on changing, as well as the weather keep on changing. So we really want to use an inverter-driven technology to accommodate for the changing in weather as well as occupancy. So at the time, there are 3 options that we are evaluating internally. First one is usually the easiest one is retrofitted with what we call LEV kit. So just replace the internal box, internal DX coil and a condenser with VRF system. Just having a VRF heat pump condenser provide heating and cooling. That will probably be the easiest system. We are still using the existing rooftop unit for fan, for belts, etc. But again, the fan motor, the belt may not be up to date, right? So that is probably the most economic solution. However, one challenge is we're not just looking for the cheapest solution. We're also looking into convenient, comfort, and energy efficiency. So this is the existing rooftop unit. Even if we take it out the DX coil, replace that with VRF condensing unit, I am sitting right here and our president sits here. So the ductwork is still very long, right? So, and then to make him the most comfortable person in the office for rooftop unit, it may make others, such as myself here, because I'm closer to the rooftop unit, I may not be as comfortable in cooling as well in heating. And then on top of that there's another upper management sitting over here. And obviously for a rooftop unit with long duct run, it's hard to make everybody really comfortable in the space. However, that is usually the cheapest solution, the most economic solution. But due to the size of our building, it may not be the most comfortable one. And second option is completely remove and replace this rooftop unit with a package heat pump system with ERV wheel. So we are utilizing, see, the compressor will be able to provide heating and cooling for the DX coil, and we're able to using ERV to still having effective heating and cooling. However, again, it will be very, very efficient compared to the existing system because we are using inverter-driven compressor as well as ERV. However, the problem still kind of remain is I have the same discharge air temperature coming off the coil, but they have to travel all the way to the other side, the other end of the building, versus this person over here and me over here. So that may not be the most comfortable solution. Therefore, we are looking into utilizing VRF with zone-to-zone ERV. Because we are utilizing VRF system that's capable of producing heating and cooling at the same time. So everybody who has a thermostat can choose their own set point as well as one mode to be operating. So sometimes instead of June 26th here in Toronto, let's imagine end of October, early October, end of September, somebody may need heating, somebody may need cooling. And we are able to achieve that heating and cooling at the same time. And actually, the more heating and cooling, simultaneously heating and cooling you use, the better efficiency that you have. Therefore, it is comfortable and efficient, and refrigerant piping is significantly smaller than air duct. Therefore, we are also be able to run the ductwork with minimum interference on the existing equipment on site. And on top of that is we're using zone-to-zone ERV that you can see over here. So, and then we are dividing the office into different zones. So let's say in the technical service area, in the accounting area, in the general office area, then depending on your occupancy, depending on the day, depending on the time, then we can increase the fresh air for that specific zone or decrease it based on that zone. So for example, cafeteria for our office, it is 9 a.m. is 10 a.m. The cafeteria, the occupancy for cafeteria between lunchtime and 3 p.m. is usually very, very different, right? So we are able to have those kind of reactive kind of solution to provide ventilation and fresh air, and heating and cooling. So the final decision is really the VRF system that you can see over here with between a rooftop unit and the VRF condenser. But it does come with some of the challenges because we want to have minimum disturbance for the ductwork, existing equipment, and for small offices, and we still want to utilize the geothermal system. Therefore, we are using VRF technology to have heating and cooling at the same time. And over here, you can also see some of the major challenge back when we are doing the design was CSAP 52, the refrigeration concentration limit, which will be even a more challenge when you are switching over to, let's say, A2L refrigerant. So, however, that was a major challenge back in 2018 when we first do a design, and 2021 when we do, 2021 and 2022 when we do the installation. So that's where the challenge coming in. However, we do have this new product in the field that's combining hydronic and refrigerant in the system. Yeah, so I'll see if I will come back to it.
So Gary, we just had a question. It was, can you talk a bit about the input sensors for DDC things with controller? Are the ceiling cassettes controlled by thermostats in the respective zones?
Yeah. So the input thermostat, the sensor is actually attached to the ceiling cassette system, so that you can see. So just look at this ceiling cassette system. So the sensor is taking the return air, and return air, which is your room air temperature, and then it's gonna look at also into your set temperature. and then controlling the linear expansion valve inside the unit to control how much refrigerant flow is required. So let's say today, like June 26th, there's a lot of sun that's in the room. That's why my return air temperature is increasing. Therefore, the linear expansion valve inside the fan coil unit will just open and closing automatically. So you still have the same set of CFN, but the valve will increase and decrease and then cooling the room temperature. So it is depending on, obviously, fan coil units or each fan coil unit can be attached to a thermostat. And you set the temperature on the thermostat, and the fan coil unit will read the return air temperature and then try to match the supply. Try to bring your indoor space down. And once you reach set point, maybe the valve can be on minimum position, still try to react to what's required and opening and closing. So it's all being done automatically in the back end. So I want to say is the fan coil unit will self-regulate, and will self-regulate depending on the valve packet. Depending on the valve position, and it's gonna. And then the larger the opening, the more refrigerant needs to be processed by the condenser. And the condenser will be able to automatically increase or decrease its speed. And this fan will also increase or decrease, right, depending on how much heat needs to discharge, as well as outside wind speed. So I hope that answered the question. So everything will be done in the back end and then really set the temperature, and the fan coil unit will just modulate automatically and working with the condenser, and then as well as the fan and the compressor inside the unit to discharge how much heat, to remove heat from the room, and in heating mode, vice versa. So coming back is we are using VRF, right, to provide heating and cooling, and then the more heating and cooling you are using is also done on the background. So let's say I want heating, and then you want cooling in October 10th, and then October 10th. Right now outside is, let's say, 10 degrees C, and I want heating, you want cooling. So the condenser will shoot out liquid gas mixture, and the branch box will separate the liquid and gas, right? So liquid goes to place that needs cooling, and gas goes to place that needs heating. Obviously, it goes a lot deeper than that, but feel free to reach out to me if you have further questions, or reach out to Mitsubishi Electric so we can talk more on those control. But coming back is another thing is, now we do effective heating and cooling, but now we also want to do zone-to-zone ventilation, right? Because people need fresh air to being awake, to be alert, and be productive. But again, just even within our own office, some people actually come to the office at 6 o'clock, and me personally, I go at 9 o'clock. So those are 3 hours difference that they are in the office and I'm in the office, right? So turn off the lights, and then maybe the unit will also be able to switch to low CFN depending on which zone you are in. So that is kind of on-demand ventilation, as well as time schedule on the ventilation side of things, to reduce how much fresh air that's really needs to be treated. And on top of the zone-to-zone ventilation, we are also introduced energy recovery ventilator to the space. So what it does is, let's say I am using electricity to cool my room air down to, let's say, 22 degrees C, because outside is 33 degrees C. But without a ERV, I'm just dumping my 22 degrees C air directly outside. But now I also introduce 33 degrees C air inside. I need to bring that 33 degrees C back into cold temperature, right? So, but in the case is with energy recovery ventilator, I will be able to using my exhaust air to cool the outside air. So instead of cooling the air from 33C to 22C, I just really need to cool it to 22 degrees C from 24. So we make the decision to go with VRF with zone-to-zone ventilation. The next thing is obviously we need to hire engineering consultant to provide energy analysis here and heat loss, heat gain, as well as on the structural side of things. Because again, the building was built quite a long time ago. Therefore, we really need to have the proper structural analysis, right, to make sure things doesn't fall off the roof, and then a proper heat loss, heat gain calculation to do to ensure people are comfortable. And especially if you recall, we did between 90 ton of air source unit, 90 ton of rooftop unit, and we are actually replaced that with 60 ton of air source VRF system. So at first I was really concerned because we are going from 90 ton to 60 ton. But coming back is, well, it's a 90 ton condensing unit, 90 ton rooftop unit that was designed based on the heat loss, heat gain calculation done back then. And then back then, the monitor, even the computer monitor, the laptop or the computers generate a lot of heat. But now we have LED lighting. Everyone's laptop is pretty energy efficient. So, and then we're using the monitors. They don't generate as much heat compared to 30 years ago. And there are a lot more people doing different kind of things, testing, QA, manufacturing, assembly back then. So now the occupancy has changed quite significantly, and as well as efficiency of the equipment that we are able to look at into the on the heat loss, heat gain calculation. Heating, on the other hand, seems to be very on par with what they did 30 years ago, so which is very good. But my personal experience is a lot more challenge to add cooling after the fact compared to heating, right? Because for heating, you can have baseboard heater, you can bring a personal heater to the office, but for cooling, it's very hard to add after the fact. So I often says, even though heating was very important, but don't overlook on the cooling side of things. And we're able to divide the entire office into 9 different zones. Because we want to, and then on top of that is we want to keep the zone, the condenser, closer to the zone they are servicing to provide heating and cooling. So we don't need to provide cold air all the way from one side of the office to the other side. So we are significantly reduce the potential of heat loss. And the result was actually pretty impressive. Was we're using different type of condensers, 60-ton condenser with ERV on heat recovery side of things, and the projected reduction in electricity is quite significant, right? Like close to 400 megawatt hour. So that is based on the energy modeling, just on the VRF and on the design. So you can see over here, we are having the energy analysis and modeling. So you can see a constant air volume through the rooftop unit versus VRF system. The projected saving was quite significant. And we are also very excited to see, well, energy modeling versus actual result. So we complete our first 1 year. So the construction takes place in, we call it financial year, so fiscal year. So we are doing the completely 1 year between rooftop unit and VRF system. And we are quite impressed with the result. Even though I work for Mitsubishi, I am also impressed with the result, because you can see we are saving about close to 50% of electricity switching from from rooftop unit with electrical baseboard heater to VRF. So just on the 1 year cycle, we are saving about close to 20 houses, 20 homes of greenhouse equivalency according to NRCan. So you guys can use NRCan calculator and see how much electricity you are able to save, and then what is the greenhouse gas reduction. And on top of that is we're looking into greenhouse gas emission, because that is our target for Mitsubishi Electric in Canada, as well as for our corporation. So we are able to demonstrate how much greenhouse gas we are able to reduce. So based on scope 2 and from NERC, the calculation is, again, we are saving the electricity and we're saving this much greenhouse gas. And if we compare that to Canadian emission factor, because in Ontario, we're using a lot of nuclear power and hydropower, so you will see the significant in terms of saving was not significant on the value itself, but again, we are saving close to 50%. So no matter which value you are using, which factor you are using, we save a lot of electricity as well as on the emission factor. And also on top of that is how much electricity bill we are actually saving. So you can look from 2023, it's about this much. So 598,000 kilowatt hour versus 1.1 megawatt hour of electricity usage. And we're actually saving about 53K a year just on switching between a rooftop unit to VRF system. And so let's look at, and then a lot of time is, well, I heard this before and people will bring up the question is, well, we do have a pretty warm winter, right? And based on memory, right? So people are comparing between thinking 2023 is pretty warm here in Ontario, but let's look at cooling first. So cooling, you can see between May, June, and July, we are saving significantly amount of electricity just because we are running ERV as well as inverter-driven compressor. And on top of that, throughout the whole optimization and utilization process, we're also looking into, let's look into schedule and setback. So before scheduling and setback in May, you can see the electricity usage is all over the place, right? Between weekday, between weekends, and with a baseline about 40 megawatt hour. But once we switch into scheduling, so weekend is pretty much just setback and shut off, right? And then during nighttime, we also have a setback and just having ERV to bring in cold outside air during the nighttime, and as well as purging the office first thing in the morning. So you can clearly see between unoccupied hour and occupied hour, as well as after everybody go home and on the weekend as well. Right, so those are weekend hours that we plotted into our into Excel just based on our electricity bill. So you can see between May, June, July, August, September, October, and then end of November, we are seeing quite significant amount on the cooling side, right? You can see over here. And then the next thing is, what about heating? So before we go into detail is, again, we implemented scheduling to have December 23rd, 2023 versus 22 and 21. So we implement scheduling. So we're having setback and shut off perhaps during unoccupied hour. So that can reduce our baseline quite significantly compared to before, and having a pretty good idea about day usage, weekday and weekends. And before we talk about heating, you have to remember we do have electric heater versus VRF heat pump. So electric heater have COP of 1, and VRF can have COP obviously more than 1. So let's say 2, 3, and 4. So let's look at winter. So in winter, January, February, March, between VRF and baseboard heater and duct heater, we also see a significant saving in heating season. But again, you may come back to me and say, well, the heating season 2024 is pretty warm. So we actually go to Environment Canada in February. So you can see 2024, they go as high as 15 degrees C and as cold as minus 15 degrees C. And compared to 2022, again, they go as cold as minus 16, minus 17, and then get as warm as minus 10 degrees C for some hours. So therefore, even if you're looking into the usage, a lot of time average hour may not be a really a good indication, right? So if I just do electric heating and that, then it may not be a fair comparison. Therefore, I am doing a comparison between, let's pick a date. So I pick 2024, February 1st. I just pick a random day, February 1st and February 2nd. And I compare between 2024, 2023, and 2022. And I make the assumption where between 6 p.m. and 8 a.m., or in the middle of the night, the building is unoccupied. Nobody's in the building, it's all locked. The interior lights mostly are turned off because the cleaner come and shut off the light. So really, so minimum, and everybody unplug the laptop and go home. So the idea is pretty good. Is at February 1st at 9 p.m., 3.3 degrees C outside, I'm looking about 142 kilowatt hour of usage. And then at 3.2 degrees C outside, I'm looking about 66 or 67 kilowatt hour. So that is also in line of what we see is, well, the COP is above 2, because at those times, really the majority of the energy consumption will most likely to be the heating. And you can see over here, but during the daytime, it's hard to say because sometimes we have guests, sometimes we have equipment turned on, but you can see 1.3 degrees C outside, 107, 124, and 153. But again, daytime people coming in and out a lot, so it's hard to make that justification or comparison. But if you look at minus 6.3, 3.3, and 3.3 degrees C, so I think that will give a pretty good idea because all the lights. Yes, we do publish performance curve in heating mode as well.
Okay. And Gary, I just wanted to mention, I know we started late, but we have about 4 minutes left. So
yeah. And then just do another comparison. Again, 9 p.m. minus 4, 71 degrees C. 71 kilowatt hour. And then again, 9 p.m. about 155 kilowatt hours. So a lot of time we are able to see the COP usage. And we do believe that it is important because we're utilizing not only VRF system, but we are also significantly reducing the load on the VRF side of things. And then we also plan ahead to have different occupancy for different area, different zones. And lastly, sorry about that. Lastly is besides the energy measurement or on the HVAC side of things, remember other opportunities before you go in. Because the first thing you do is you should reduce your load, right? So it can be done through LED lighting and then building envelope through just seal the windows, seal the doors, get better windows, and better building operations. Turn off the unit you don't need to, right? And then we're also, for Mitsubishi Electric, we're also looking into water usage as well as renewable energy. So those are opportunities that we can look into, but mainly is because we do believe that just switching between rooftop unit and from a rooftop unit to an inverter-driven technology, we're able to save a significant amount of electricity in cooling, as well as in heating from a baseboard heater, as well as other type of technology. So, yep, that's just a short run on my presentation. Sorry for being late. So if you want to learn more about it, feel free to reach out to us.
Yeah, and I want to be fair to Gary. It was not his fault he was late. As we were trying to figure out what was going on, I think there was a setting within the software, Gary, that was preventing you from getting on. And so that we don't know how that setting got turned on. It was only turned on for your session. So I apologize there. We did just get another question come in, though, if you could quickly answer. Is there any limit to the length of piping we can have from the BC to the indoor unit?
The VI piping is I don't have that on top of my head. We can share the table with you. So, but definitely very, very long pipe runs will be able to accommodate for a lot of different projects. And we don't just do offices. We also do high-rise building, low-rise building. So the pipe size, the pipe length is usually not a big issue. And also pipe length, usually the more pipe you use, the longer it is, the more expensive, right? Your project may be, and as well as more refrigerant you're gonna use. So therefore, it's more of a strategic kind of investigation that we need to do.
Okay, great. Was there any other questions? We got 30 or so seconds left. So, but we will follow up this and we'll have an article about this in our next issue of Plumbing and HVAC as well. And we'll follow up to it with links to the video. And if anyone had any questions, I'm sure they can reach out to us and we can make sure that we can get them answered and so on and so on. So, but again, thank you, Gary, for joining us today and explaining this retrofit. And our next session is about to start any second now with Sandy from HREI. So we'll join everybody there. Thanks again, Gary.
Thank you.